Hello and welcome to another episode of the AI Show. This is Seth coming to you on our brand new day, Mondays. So listen, we were supposed to do our show on Monday, but we were told not to. Because we had other announcements at Microsoft in the Monday, Tuesday area that also had to do with AI. It was great. You know what? That stuff is cool. Did you see the announcement? Again, welcome to this episode of the AI Show. Where's everybody coming to us from? Tell us where you're coming from. I'll give you a little shout out. And then we'll talk a little bit about what we're doing today. Today is only a 1 hour special. In the middle of the week, we are moving to Mondays at 8:30 a.m. to catch other people around the world. It says, please don't bring Monday back to us. It is all forgotten here. We're trying to make Mondays. I don't even know how to show anymore, everybody. We're trying to make Mondays a little sunnier by bringing to you the AI Show live every Monday at 8:30 a.m. So next week we'll be here again. This time, no guest. I feel like I've been neglecting our work, you know. So I feel like because we've been neglecting our work, next week we're going to be doing Rochambeau again. Lake Stevens, Washington, welcome. Lovely place. Lovely. Uruguay. Bienvenido. Fernando. Un placer. Welcome. Thanks for coming. Today we've got a really fabulous guest. And then we're gonna take the cobwebs off of Rochambeau a little bit and see what we got going on there for this brisk 1 hour show. Another Fernando de Madrid. I lived in Spain for like 2 years, southern Spain, Málaga y Sevilla. Delightful. Romania, OG Latin romance language. I love it. From a very warm Minnesota, 40 and sunny, Cassie. No, Cassie. I'm saying that this is for me because it's 40 over here too, and it is sunny though. So, by the way, I did get a pop filter, so I can say stuff like pears and pickles, and it won't hurt us a little bit. Looks like we've got someone from Germany. Welcome. Das ist sehr gut. Das ist unglaublich. Welcome. All right. So today, let me get my pandemic purchase out. My pandemic purchase to talk a little bit about what we're doing today. I got my pen ready to go. Let's see if it works. There it is. Oh no. It's focused on the wrong screen. So listen, I'm gonna have to write it with my fingers, which is gonna be terrible. I need to tell you, I recently changed. Here, let me show you. Hold on, stand by. I recently changed my GPU, and so all my screens are out of whack. My GPU is now, get ready. Boom! Look at that. Yeah. This is my new GPU. GeForce RTX 4080. But because I did that, it messed up my screen placement. And so now for some reason it thinks my primary screen is on the other one, and it isn't. It's a liar. So let me write it with my finger. Today, number one, we have Vlad. And it's going to be very short because I need to write this. Vlad, stable diffusion on ACI. We'll tell you what that is. Well, we'll tell you. He'll tell you. He's a smart guy. And then number two, we're going to get into some Rochambeau. Whoa, I write pretty good with my mouse. Questions here. Very good one. Can your new GPU run Crysis? I'm going to say yes. Mostly because I don't know. What? I think it's a video game. Hello from Kenya. Delightful place. I went there. It was great. Yes. Fancy new GPU. What am I going to do with all that power? Mostly play Minecraft with pixel shading. That's all I'm going to do. And I forgot. It's been so long. I'm supposed to like turn my other music machine on so that I can play music in the background. I have maybe I should do a thing on my setup one of these days, but I have like a voice processor. I have a machine that plays sound effects, and another machine that just plays music. It's quite good. Okay. So, without further ado, let's bring Vlad on. Vlad, are you ready? Give me a thumbs up. What's up, my dude?
Word. Hello. Everything is up.
Oh my goodness. I had the most delightful time talking with Vlad about Stable Diffusion. Do you want to give folks any preview, or should we just show it to them?
I think, yeah, it's best if we showed it to them. But yeah, I'd also be curious if you managed to run it on your new GPU.
I should try, but like I'm telling you, my computer feels a lot snappier. And for those that don't know, Vlad, I'll tell you the reason why I had to get a new GPU. This is what I told my wife. I had to tell her this, but it's true. It's because my computer screen started like flickering off, and I could tell my machine was still on and processing. And so my old GPU, which was an RTX 3080, I think was giving out. It's up there. I can see it right there on one of my shelves. I should bring it. It's huge. Maybe I'll bring it down during when we show. It's huge. I think it stopped working, but now I have a 4080 and it works. So, Vlad, do you have a nice GPU in your machine?
I have a GPU in my machine. And sometimes I fantasize about taking a hammer and seeing if that flicker problem arrives after whacking it a bit, so that I can justify the upgrade. But
I will send you a hammer. Vlad's like,
yes, please.
No, Seth, stop talking about your GPU. All right, my dudes and my gals, we're gonna play the show. You're gonna enjoy this, I think. And then Vlad is graciously, he's gonna stay and answer your questions. And so, Vlad, what time is it in your time zone over there?
It's 6:39 p.m.
But at least it isn't a Friday. We used to have people come on like on a Friday. It's like 8 p.m. and it's like, hey, I'm spending my Friday night with Seth. I have a sound effect for that. Yeah, we don't want to do that. And so now a Wednesday is okay.
Yeah, at least it's not a Monday.
All right, so let's play the show. Take a look, my friends. You're going to love it. You're not going to want to miss this episode of the AI show. We're talking all about how to draw anything with Azure AI and Stable Diffusion with my friend Vlad. Make sure you tune in. Hello and welcome to this episode of the AI show where we're talking all about how to draw anything with Azure AI and Stable Diffusion with my friend Vlad. Why don't you introduce yourself, my friend?
Hi, Seth. I'm Vlad Iliescu, an MVP from sunny Romania. By day, I like to say that I work on machine learning and data engineering at a beautiful software company here in Iași called Strongbyte. Happy to be here.
I'm excited to talk to MVPs because y'all have a wealth of knowledge, actual ground, feet on the ground kind of knowledge of doing stuff for customers. So before we get started, I thought we would talk a little bit about what Stable Diffusion is, and then maybe how you got it to run, and then you could show us. What do you think?
Sounds great. Well,
all right, let's start with Stable Diffusion.
That's what you took the words from my mouth.
Nice.
So I think one simple way of explaining what Stable Diffusion is comparing it to dall-e 2. Surely you must know about dall-e.
Yes, I've heard of dall-e, yeah.
From OpenAI. Yeah, well, Stable Diffusion is like dall-e, but different. Yeah, on the one hand, dall-e is a generative AI model that can generate kind of whatever you ask of it, but that's exposed as a web API, so it's really easy to integrate as a developer, right? You don't need to install it anywhere, you just get an API key, pay for the privilege, and then integrate it in your applications. On the other hand, Stable Diffusion is an open source model. So that means that's a blessing and a curse, by the way. That means you can do anything you want with it. You can run it on your own hardware. Yeah, you get access to the weight. You can even retrain it and fine tune it on more specialized image sets. But then you have to run it, right?
Yeah.
You have to configure it, and it becomes more difficult.
So let's see if I'm understanding correctly. Stable Diffusion is a way to generate images from text. It's open source, but everyone knows that open source is like free, but free as in puppies. You can get a puppy, but then you got to take care of it, and sometimes it makes a mess. But if that's something you want to do, you could totally do that. Am I getting this right?
That's exactly the experience I had when having a puppy. It's spot on.
So what are the general challenges with running something like this on your own that you ran into, and then maybe you could show us this stuff?
Absolutely. Well, I'd say the first challenge was that I wasn't able to, because I'm running an older Mac, so no M series, just Intel all the way. And even though I have a video card, it's an API card, so Stable Diffusion didn't run on this. But I really wanted to try this out, really wanted it. So I turned to Azure ML. I knew there were these compute instances that could also I could also get GPU access on them. Mm-hmm. So I started looking how I can configure Stable Diffusion to run there, and lo and behold, I managed to do it, and it's been quite fun. It cost me more time researching Stable Diffusion than I'd like. Once you start generating images, you want to generate the best images, and then you get into prompting, and then 1 week later you come out in your bathrobe screaming Eureka. But it's been quite a ride.
Well, here's the thing about technical stuff. I feel like there's always like one person that goes through the pain of figuring it out, and then they show us, and we're like, thank you. Now I don't have to come out of my bathrobe and have a Eureka moment. I could just do it. So can you show us Stable Diffusion and then show us maybe how you got it to work?
Absolutely.
All right, let's do it.
Right. So what you see here is one of the many interfaces on top of Stable Diffusion, right? An open source interface that you can use to generate, well, anything using the power of AI. So just to prove that I'm not just exaggerating, I wanted to ask you, Seth,
yes.
Can you give me a good image, a scenery for your perfect vacation?
Okay, so let's try rendering that. There's like mountain people that love mountains and beach people that love beaches, and I am a sunny beach guy. So let's try that.
Let's make a sunny with two N's, but also epic and also epic. Also epic beach. Do you like waves? Who doesn't like waves?
Oh, I know. Is that even a question? Of course I like waves.
Of waves. But not threatening waves. But just lots of waves.
Friendly waves, of course.
Friendly, the friendliest waves.
Yes.
Right. So right now, how does this work? Yeah, the Stable Diffusion model is wow. It has taken. There's no beach.
We didn't tell it friendly waves, so it decided to make scary waves.
More friendly, more increased friendliness. Right. Yeah. So how did this work? Basically, Stable Diffusion models work by generating a lot of random noise, and then gradually, through a series of steps, and I'm using 20 steps over here, refine that random noise towards an image that kind of represents what I asked for it. Mm-hmm. Lots of waves, emphasis on lots. And here, I think is that a puppy?
It looks like a stuffed animal, like a stuffed animal on a surfboard.
Okay, but and I'm just gonna update the image a bit. I'm gonna use the same seed so that we don't get a different image, right? So we use the same seed. It's the same image, whatever you ask. And I'm just going to remove the surfboard. Yeah, who doesn't? No surf, just waves.
Surfboard. So the top one is what you want, and the second one is what you want to take out.
Yes, with a B. And I'm fingers crossed. We have never tried this before, dear audience. And
oh, nice.
And
there's walking on water.
It's the end of times. That's the perfect vacation for Seth. My gift to you.
This has got to be the perfect. I'm excited. I'm excited for this one because this means that we can both walk on water during our vacation. It's a magical moment for both of us.
Yes. So happy we can share this.
Yeah, and so here's the question: is this whole thing, did you build it from scratch, or how did you? Because this is your instance of this thing running, right?
Yes, I stole other people's work, borrowed other people.
Yes,
that's how we. But basically, this is an open source interface on top of Stable Diffusion, which is also open source. It's automatic 1.1.1 fork, and I'm running this in Azure. Now, I'm going to use a neural network that I've been training for some time and predict the next question that you're going to ask. And that's going to be, but Vlad, if you're running this on Azure, why do you have a Gradio URL?
Yeah, that's what I was looking at. Because it's like, this feels like a totally different service. And I'm glad you kind of brought that up. How did you set this up?
Yes, well, with the power of AI. But basically, I'm using an Azure ML studio, right, where I've created the compute instance. It's this beefy guy called Biff, and here I'm using the integrated terminal, this integrated terminal, to run. Well, let me just stop it. To run Stable Diffusion. Now it's totally not going to work if I refresh it because the service is not available. Yeah. So what happened over here? Azure ML compute instances are really cool for running notebook jobs. We all know that. Yeah. If you look at the documentation, everybody's mentioning running notebooks, and that's a pretty big use case. But what I wanted to try over here is see how they work for running applications. Yeah, not just notebooks, because you can totally run Stable Diffusion in a notebook. You can write a Python code, but I wasn't in the mood to do that. I just wanted a nice UI. Sometimes I just want to click buttons. It's so relaxing, right? So I wanted to see how you can configure these compute instances to run, and one of my favorite ways to do it is with the embedded terminal. So that allowed me to, for example, to access this this interface, via Git. I did a Git clone. Let me see. Let me show you. So right now, I'm on branch master. I have some added files, but I am in the directory for this application. Yeah, I can manage the compute instances from the command line, and I can do anything.
It's like a computer in the cloud, right?
That's what I was trying to say with too many words. Thank you,
Seth.
Seth.
The reason why you're doing this is because you couldn't run this locally, right? Because this needs a GPU to run, or it won't work. Am I right?
Definitely, this needs a GPU to run. Plus, in some cases, so even if I were able to run this, it would still be rather slow. You've noticed I'm running, I'm generating an image in about 3 to 4 seconds. So that's quite fast. On maybe a higher end video card on my machine, I would do the same in about 11, maybe 12 seconds, depending on the resolution. So it would be dramatically slower. Plus, if I were to train my own models built on top of this, I would need a significant amount of VRAM, right? So, for example, an anime model, waifu diffusion, trained on fine-tuned on a series of anime characters, it took about 30 gigabytes of VRAM. So that's out of the realm of consumer video cards. It's not. I wouldn't want to pay that much on a GPU.
Yeah, that makes sense. So you clone this repo, the Stable Diffusion repo, and
Yes.
on the compute instance, and then does it how that UI was that just part of the repo, or how did that work?
Yes, that UI is actually part of the repo. That's they're using Gradio. Yeah, Gradio is a machine learning. It's an UI for building interfaces in Python, but it's very much used for machine learning. And they have very cool sharing option, which when ran, it talks to the Gradio server and exposes the application over there. So that's what I was doing. Actually, you can even see here in the logs, yeah, running on public URL over here. By the way, as a hint, if you were to set this up for yourself, do set a username and a password for the for the public URL, because sometimes they're guessable. And at one time, I didn't know why images were being generated that I never asked for, and then I discovered the magic of authentication.
Nice. Okay. So this is you're using a compute instance that's generally a notebook machine for Azure ML users to try something out for people to see. Now, beyond just like cloning and running, was there anything else you had to do, or how does this all work?
Absolutely, it was quite interesting because on the one hand, it needs a lot of packages, right? You don't just git clone and run. Due to the nature of these models, yeah, they do require, amongst other, PyTorch and the NVIDIA drivers and CUDA and all that stuff. And the authors of this UI tried to make things as easy as possible. So it was really smooth once I managed to get other things to work for this particular Linux machine. But yeah, pretty much it's git clone, then set up a conda environment. I'm a big fan of conda environments, because then you get to specify not just your pip packages, but also the version of Python. You have them precompiled. I think it gives a much better separation between environment than just using the pipems. So
That's
I
cool.
created a conda environment. You can even see it here. It's A111 SD Web UI. It's activated, where I installed everything. So if I'm to I don't know, use another interface, maybe not automatic one, but invoke AI, I can create a new conda environment and install the packages over there, so that we don't get clashes, because that's really important.
This is cool. And then what's the command? Is the command that to run the Gradio app? Just can you show us
Yes.
that, and then we can. Oh,
Yes.
let me move my faces. Okay, cool.
Yes, it's this beauty. So basically, what I'm doing over here is just activate the conda and then do an accelerate launch. The automatic fork, the automatic web UI, has some more user-friendly options to run. They have some shell files, but I do prefer the control that I get from just running the raw command. And you can also see the username and passwords I've set. So now you can go and generate everything.
Now we can go look at it. Okay, so this is really cool. So just to summarize, you found this amazing Stable Diffusion model. You're like, I want to try it out, and you basically were able to run it on an Azure Compute instance just as is, without very many modifications. I mean, just creating the con environment, or was there anything like, was there something that you had to go through for it to work?
Actually, no. That's a really good highlight. I was able to run this with no modifications. So just making sure we have all the needed packages in the right conda. And I'm mentioning PyTorch because I've had some issues with that, but in the end, yeah, managed to do it and document that as
That is
well.
amazing. So if people want to read more about this and they want to see your journey, did you write this down anywhere?
Yes, it's on my blog. I think you have the link.
Yes, I was like tossing it up for you, be like, you should look at my
Thank
blog.
you.
I looked at it. It's great. I love your writing style. That's like, hey, I wanted to try this, and then this didn't work. So yeah, absolutely go to the blog. And then for those that want to know more about compute instances, we have a link here for you as well to learn about Azure ML compute instances, and then also stable diffusion. Any final words, Vlad, you have for folks watching?
Absolutely. They should try using compute instances for like whatever they can. It's I really enjoyed working with them. And do I have one last final minute to show a really cool thing that
I do. If you have cool things, I want to see them. So let's see what you got.
awesome. I really like doing stuff in Visual Studio, to be honest. So I got quite excited to find out that you can do development in Visual Studio on the remote machine. So right now, what you're seeing is me in VS Code connected to BIF, good old BIF, and accessing the files. These are some of my previous generations. I'm really proud of this one. But basically, right now we're looking at the file system for the Stable Diffusion Web UI. We can, I don't know, edit the documents. You can do git commits if you really want.
Hold on. Wait, this is Visual Studio Code, but running on the machine in the cloud?
Yeah. Yes. It even has the extensions over there. So I get two sets of extensions. You see, I have the local ones, the ones I'm using on my local VS Code, and the ones on BIF, the ones installed over there. For example, I was able to install an image gallery just to look at this, especially for remote development. So it's really cool. I'm really excited
Wait, so
about this.
how does one do this? Like because you're on the machine, but you're on your Mac right now, but you're on the machine in the cloud to do your Stable Diffusion. Like, how is this accomplished?
I hope you're not expecting a smart answer from me, because you go in the compute list and click VS Code. So I was when I saw this, I was like, what?
You said one more thing. I didn't think it was gonna be that. So, in theory, you could effectively run everything as local on Visual Studio Code, connected directly to that compute instance, and see everything that's going on.
You even get the terminal. So it's beautiful. One thing to have in mind, though, is
Yes.
and that's really important, is that if you're connecting with VS Code, then the cloud machine will not automatically shut down because it won't appear as being idle.
I see.
So if you kind of need to either exit VS Code or shut it down manually, right? Because I'm not sure if I showed you, but I set this to shut down after 30 minutes of inactivity, because nobody likes a big cloud invoice.
Not a big Azure. Well, you said one thing, but this was actually a huge thing. Thanks for showing that.
Sorry.
Any final words for people that are watching?
I have one other thing.
Oh, you do? Show us the other thing. This is great.
So you might wonder, have you ever wondered how to download these images, or the things you generate, or how you can where they're stored?
I'm assuming they're stored on the compute instance, right?
Almost. No. So on the compute, you get some really ridiculously low amount of free space on the compute instance. It's just 128 gigabytes. You fill them up in 3 Conda instances, but they're in the storage associated with the ML Stable Diffusion workspace. And in the storage, it's not in the containers like you might expect from AML. It's actually in the file shares. So you get a file share, and there you have everything, all the files over there. So what this means is that if you create a new compute instance over there in the same machine learning workspace, you will share this code. It will also be mounted in there. You will not share the Conda environments. You'll need to recreate them.
Right.
But then two people can work on the same code.
So what I'm understanding now is a compute instance is generated, but the backing file storage is in the cloud. And so in theory, you could replace your compute instances at will, modulo the Conda environment, and still everything is there.
Yes, exactly. And if you need to change regions, right? Because these are per region. Let's say you find that in East US it's cheaper to run GPUs than in West Europe, where I'm at. You can just use Azure Storage Explorer to move these from one cloud to the other without having to download gigabytes and gigabytes of files.
Vlad, this is delightful.
This is pretty cool. Yeah.
Do you have any more special things? Like, did you bring cookies for everybody too?
I might. No, that's it. That's awesome. One last final thing.
Do you have any final words to summarize? If you say one more thing, I'm gonna be so excited about it. But any final things to add?
Well, just that I was really excited to be able to run. So two technologies I was really excited about. Yeah, on the one hand, Stable Diffusion. It's open source. I love open source, but as you said, sometimes it costs time.
Like puppies.
I was sorry.
They're like puppies. You got to clean up after them.
Yes, exactly. I flashbacks.
Yeah.
In my case, but I was really appreciative of the fact that with compute instances, I was able to run them reasonably fast without a lot of effort. So yeah.
Awesome.
Stable Diffusion is awesome. Compute instances are awesome. You should go try them out.
All right, my friend. Thank you so much for being with us. And thank you so much for watching and learning all about how to draw anything with Azure AI and Stable Diffusion. Thank you so much for watching, and hopefully we'll see you next time. Take care. You're not going to want to miss this episode of the... Oops, I pushed it again. Sorry. That was my bad. Vlad, are you still here? But there you are. That was delightful, my friend. Did you watch it? Did you watch it? Did you like how I edited all the other stuff out?
All the bad stuff. Many thanks.
I didn't edit anything out of that. It was just like one thing I edited when we switched to his screen. The rest was all gloriousness. All right, so here's a question. Get your questions for Vlad. He is so nice to be here. Here's a question, and I don't know if I know the answer to this one. Are there any Stable Diffusion implementations that have far lower performance overhead so that they can be run as part of a real-time application? For example, generate images in real time at 60 frames a second.
So there's research being done on distilled diffusion, which basically would yield something like 10x performance improvement. So 10x is huge, right? If we get something like if we need 20 iterations to build an image, and on an V100 we need we get about 7 iterations per second, so 2.5 seconds. Then a 10x increase would mean that it takes less than a second to generate an image. But from that to about 60 frames per second, there's still some time.
Yeah,
that's it.
I bet it's like you could probably make some cool stuff, that's generative, like a movie thing. But it would be like how they render Pixar movies, right? They put it all in there, and they're like, all right, these machines are going to crunch for a weekend, and then you get your movie out. I bet you could do that kind of thing today.
Yeah, pretty much, but not with the same quality, because basically there's research being done in this regard as well. But it's often a bit difficult to maintain the same scene, the same composure, to have a fluent character, rotating heads and movement. But Google's doing some interesting research here. No code that I know of as of yet, but it's really promising.
Because you would probably have to, if you wanted to make a video, you'd probably have to do a stable diffusion, but then you'd have to add like another dimension to the vectors of over time, right? And then you could probably get cross frame stable diffusion stuff happening, but that would be a big model.
A big. I've seen some work being done with I believe EBSynth. EBSynth, it's a software, at least for the Mac, that can be used to map a movie, to basically to change the characters in a movie, to change at least one character. So now if you have this video of me and then you draw some cool mustache all over, and in theory you could make the same video of me with the cool mustache. But
yeah.
So I've seen some really cool people doing themselves as zombies, really cool, with stable diffusion and EBSynth. But from my tests, I probably don't know how to use it as well, because it was terrible.
So there's a lot of cool things you could do. Like basically, we could all be like, yeah, what's that one Star Wars? I shouldn't say it because I don't want to get fined or anything. But you could create your own industrial light and magic shop just with AI techniques, right? Which would be really cool. Okay, here's another question. Let's see. Here's another question. How good would you say is stable diffusion generate variation or add content to existing images? I know you started talking about that.
Yes, it's again. So based on my tests, you get, so on the one hand you have the text to image model, which you describe a scene or some characters or some scene with a character, and it just spits out the image. But then you also have the image to image models, which can be used to take a scene and alter it based on your description, which is really cool, right? So you can draw something like a kid's drawing to set up the composition of a scene, and then just do everything from Lord of the Rings to the Matrix with that same composition that you used. So that's really cool on the one hand. Then there's in painting, which basically you define an area in an image, right? Any sort of area in an image, and tell it to, I don't like this area, just put something else here. Like I don't like this bird, just put a military airplane because I'm a big fan of them. Right. And it will render that, and depending on how you set things up, it will render that new object in the scene as inspired by the previous object or something entirely new. It's really cool to use it to draw monsters in the fog, right?
Or to remove people from images that you don't want in there. Get Seth out of this picture who's trolling us in the background, and you just put a little thing and it would remove it, right? I think I've seen that stuff.
Yeah, it's pretty awesome, to be honest.
That's cool. All right. So any other questions, make sure you get them from get them in the pipeline so we can ask Vlad. But for those that are wondering, just a reminder, the blog post to see what he did is here, aka.ms/stable diffusion /Azure ML. It's a lovely little John. What are you working on next? If you could tell us.
Well, to be honest, I've done some also with stable diffusion. I've done some experiments with just putting, everybody wants to take good pictures of themselves. I can't manage to do that, so I'll do it with AI. So my plan is to evaluate several approaches for bringing a character, a person or an object, to stable diffusion, right? Because right now, if you ask it, okay, let's draw Seth on the beach chilling with a Mai Tai, maybe two, who knows? It will not do it, right? If you put Tom Cruise, maybe. I tried it once and it had so many fingers, it hurt. But
my seventh finger hurts.
It had fingers as pineapples. It was terrible.
Oh no!
I'm pretty proud. It's an image I will not get out of my mind. But
now I won't either. So.
Yeah. if you want to do that with yourself, right, or with me, you can. And there are a few approaches for doing that. Some a classic one is textual inversion, but also there's newer ones like Dream Booth or even LoRa. And I'm really interested in LoRa because it's quite new, and as opposed to Dream Booth, which trains a new model, it has gigabytes of data in there. LoRa has megabytes of data. So looking forward to having the time to to play with this a bit.
Yeah, I've heard of LoRa. It's a low rank approximation of some of these matrices, so they're able to squeeze a lot more into the operations underlying, which is,
Yeah.
I think, super cool. Well, my friend, any parting words for everyone here, or do you have like one more thing to show us or to tell us?
No, yeah, not today, maybe next time. So
I
no,
love
thanks so much for joining. Hope I sparked a bit of your imagination, and definitely stay in touch.
Yeah, and for me, if I get any spare cycles, I'm excited to see if I can't put a stable diffusion model onto an Azure ML endpoint. I'd love to try doing that. That would
Yes,
be
yes,
fun because then I could do stable diffusion all the time.
yes, yes. That's something to take into account.
All right, my friend. We'll see you next time, Vlad.
Take care.
Cheers. Isn't that dude just a delight? He's such a cool dude. That was a great session. We're getting some words here. That was a great session. Thanks so much, Vlad. You're the best. Here's another question. Will it be able to draw in between for real character animations if you give it your own images for the start and the end soon? I see. I don't know. It's something I want to try. There was a question earlier on too that I want to bring up here because it was actually a good question before here. Let me scroll. I'm scrolling. There before was it before or after the echo? I don't remember. Here it is. This is a good question. What's with Azure only making AI services available to partners? This is a good question, and I feel like I need to answer it. That's not true of all of our AI services, but the newer ones, yes. There is some responsible AI practices that are still being fleshed out and made concrete. And so, as we develop those practices, it's important that we release these things. We've done a lot of work internally to make sure that they're safe. We have councils of people that look at this stuff, of a diverse set of people that look at these models and try to make sure that they're used ethically. As we move to the next ring, we need to, as we work with partners, we need to work more hand in hand with them to make sure that the responsible AI practices are also followed, or maybe there's something that we need to learn so that we can make them more responsible. And so that's the reason, one of the reasons, amongst others, why some of these newer services like GPT-3, and then whenever we release a chat GPT, I think they announced that we're going to do that. That's why. It's a good reason. We don't want these things to get out there and be used inappropriately or in any way that could potentially harm another human being or adversely affect their lives. It's just not something we do. It's not the kind of company we are. It's not something I would support. And so that's one of the reasons why. Hopefully that answers your question. It's a good question. Um, it's a very good question. So hopefully that answered your question. That's why we're releasing to partners first, so that we can learn together with them, and then hopefully everyone can use it once we get the safety mechanisms. Because here's the thing, once you have something go public, there's always that one dude that messes it up for everyone, and we're all like,
this is why we can't have nice things. You know? This is why we can't have nice things.
We don't want to have that kind of situation. Where the AI is like, you need to use me correctly.
You need to use this correctly.
Do you know what I'm saying? That's why. It's a good reason. Hopefully that answered your question, by the way, because it's a good one, and I'm not one to shun questions. So as you see us come up with these new services, you'll see that we will have limited release initially, and then we'll start to put these things out to more people. Here's another question. Thank you, Seth. Couldn't they release highly limited regulated versions of the model so that people could start exploring integration with their application? Maybe. It depends on the model style. It depends on the model style. With these new generative models, it's hard to predict what they will put out, especially if you release the APIs in a naked way. Because if you think about it, like your GPT family of models, particularly large language models, all they do, and this is important. Hold on. Important message about large language models. I didn't time that right. Important message about large language models coming up next. That was better. Large language models, particularly the GPT style of family of models, all they do, and this is important, and I wish everyone in the world knew this. So everyone in the world, all these models do is they take a 4,000 token context window and generate the next n likely tokens. And for practical purposes, let's pretend tokens are words. They're not, but let's pretend. So these models, given a context window of 4,000 tokens, generate the next n likely tokens. That's all they do. It turns out that because these models are so big and powerful, they have, in some sense, captured for sure syntax and some semantics over language. And because of that, the next likely n tokens are amazingly realistic. And so to answer your question, could we release a limited model? No. We could put guards around it, but we need to learn how to make those guards. We have put guards around these models with our internal RAI frameworks, but as we release to partners, we're going to learn more about that. So that's why, particularly the Chat GPT style of models, which is a GPT family, which is in the GPT family, just been trained over transcripts of conversations. That's why it's so good at talking to you. But here's the secret. It's not talking to you. I see dead people. No, that wasn't part of it. That wasn't part of it. But hopefully that helps. But these are really good questions, by the way, and they're questions that need to be asked, and we have thought of them as a company. Now, I don't speak for Microsoft. I speak for myself, but I do speak for things like Azure machine learning. So hopefully that's helpful. Good question. Hopefully that answered it. Let's remind ourselves in the last 10 minutes, unless you have any other questions, I'm happy to answer them. Let's go back to this goodness here. Boop. I got my pen to work. Hey, yo. Woo. Let's see. Did I get it to work, or is this all lies? It's all lies. Let me turn it on. Okay, you should see. It's working. Yes. Okay. So for our Rochambeau project, I do want to finish this year. This is my New Year's resolution is to finish a Rochambeau app that you can play, that anyone can log in with Twitter or whatever, because I don't want to keep usernames and passwords, because that's something I don't want to do. A New Year's resolution where you can log in and play rock, paper, scissors against a UI. Against an AI. Or maybe, and this is a stretch goal, other people. Oh yeah, the Twitter API stuff is hard to do. There isn't, because we decided to use Next.js. Janet, by the way, I forgot to say, welcome, Janice Jew number 7. Because of Next.js, they have something called Next-auth, which makes it super easy. You just gotta. It's really nice. They do the whole OAuth token thing. It's really nice. I zoomed out. Sorry about that. So for sure, play against an AI, and then maybe even other people, but then make it also so that you can train the model. So, for example, someone invariable, because this thing that we made is trained on like my picture. which, as you know, I don't look like other people, and neither do you, and that's just fine. Sorry. And so if people accept the terms of the service, which means that your picture may show up in our show, and you're okay with that, then you will submit images to the service. And what I will do is like ML ops it so that every, I don't know, every Saturday night, while computers are just sitting around, like wanting to, like, I want to do something, we can just retrain the model and then re-update. So the endpoint is fresh every Monday morning, So this is where I want to get to. This is where I want to get to with this. And so I'm hoping I can do this by the end of year. And because we really only spent like an hour on it. Maybe I need to like do like a special, bonus Twitch thing where I'm live coding this thing for 2 hours on a Friday. Usually for me, Mondays and Fridays are awesome because all my meetings are usually in the middle of the week. And so Mondays and Fridays are awesome because I can do extra. I can write code, which is sadly something I don't get to do as much as I would like. Okay, so by end of year, have this, and as you know, there is Rochambeau.ai. We actually bought this, so you can go and you can play. But I'd love for this to be something that everyone can look at and be like, oh, this is a full MLOps process where there's new images that come in all the time. The model gets retrained, and it's getting smarter and better, and etc. And I can switch the model type whenever I want, and it doesn't matter. No one knows. It's just an endpoint that's called. So this is where I want to get to with this one. Great question. So hopefully we do that. We'll go in there and look at that. Another thing from our good friend who's asking amazing questions. When I say limit, I'm thinking training only on, say, research and academic papers, etc. Following your token analogy, this should lead to more moderate. Yes, we do. OpenAI has released the Chat GPT that people can play with. But yeah, I see your point. Feel free to email me because I think I'm kind of understanding what you're saying. But yeah. But the reality is the reason why, because I like your thoughts on the moderated language generated, because it's trained over such a large corpus. I think that's why it gets for sure syntax and perhaps more semantics than usual. It's the volume I think that helps. But again, that's just my opinion. I'm just here so I don't get fined. To quote the venerable Marshawn Lynch. Okay, so let's take a look at where we left off and look at this project, and then we'll probably be out of time. Maybe I'll come back on Friday. Oh, I need to close my .env. Okay, cool. Okay, so you remember. This is the AI bit, and this is the web bit. And if you want to know where it is, let's go to GitHub, github.com/AI. Here it is. So this is where the Rochambeau project is. You can all go look at this. And if you go to Rochambeau, I think it. Oh yeah, see, it's still there, and it's just pretty crappy. Like, I need to fix this. This is embarrassing. We have more self-respect than all of this. Like what is this? Is that a broken image link, Seth? What are you doing to yourself? Like, what is that? Like, someone should call me. Hey, Seth, can you fix your horrible site? Yeah. Thanks, Seth. Indeed. Let's see. Here's a question. Do we have paid or free instances like Google Colab? There's certain programs that you can get into that will get you some compute, GPU compute. But generally, the compute we have is paid for. But here's the thing about our compute is you only pay for what you use. And we really mean that. Like, for example, here is my compute clusters. This is my compute instance. Look how nerdy I am. I called it Saruman. This is the one I do experiments on. Note that it's turned off. And the other thing about it is I don't pay for it. Oh, how likely? Very likely. I'd say it's almost like a job for me. Yeah, please contact me. Thank you. There you go. I'm going to get in trouble. So notice this one. This machine costs $3.60 an hour when it's running. It's not running. And I have put this limit upon myself so that at 6 p.m. every day it'll shut down. It doesn't care. It's like, go home, Seth. So that's what that does. So that's every day it shuts down at 6. Like, for example, I need to start it today because I have a customer meeting. And every time, it's so dumb. I logged in. This is my favorite. Peggy, you're the best. I wish I could say a cat sat on my keyboard. I can't. My typing sucks. Okay. And then here's my other compute. It's starting, by the way. Here's my compute cluster. This is Gandalf. This is a big machine. And it's because sometimes we train some big stuff. This is expensive. It's like $12 an hour. But most of my jobs don't run for that long, and these things are shut down. And you could easily use like an NC or a NC6, for example, to do some of these jobs. So great question. Great question about that. So yeah, Rochambeau AI is here. And so make sure that if you have any tips or ideas or want to do something with Rochambeau, let me know. But I gotta start playing our walk-off music here. Because we are almost out of time. Wow, that went by fast. How about that? I'm used to 2 hours. I'm like, oh shoot. So what I'm gonna do next time is, if I have some time, I'm leaving on vacation, so I'll be here next Monday for some Rochambeau. But the week after that, I'll be out of town. I think Cassie's going to be helping out. Cassie's amazing, by the way. I think I need to figure out how I want to do this web thing, what I want it to look like, etc. Then once we get this web thing going, we'll start putting these images into storage, so that if people submit images, we have to put a login, and then people can submit images. Then we can start to figure out the MLOps thing, because I think that's what I really want to get to. The most important part for me is, what does the MLOps process look like in an actual application, actual in air quotes, one that actually, runs. And I want to show you what that looks like, because I think a lot of the people I talk to struggle with doing MLOps. And I don't want you to have to struggle. Next time on the AI show. For those of you that are wondering, join us Monday, February 13th for our live stream. Let's get back to work on rock, paper, scissors with yours truly, Seth Juarez. It's going to be delightful. Come with your questions. I have the attention span of a squirrel, and so if you ask any questions, I will immediately be like, I want to answer your question. And so again, make sure you tune in for that. We're going to be doing rock, paper, scissors, hopefully fixing this up, getting into a place where we got some MLOps going, and you can interact with the website yourself. So this is it's all publicly available. You can steal the code. It's not stealing, because you have permission. But hopefully we can get to a place where we have some amazing MLOps going in there with a cool app that you can actually have fun playing. And if it makes a mistake, you can submit images for it to retrain. So with that, I want to say thank you so much for your time. I know your time is precious, and I'm so glad you decided to spend it with us. see you next time on the next episode of the AI show where we're talking about rock, paper, scissors, ML opsing the whole process. Thank you so much. And hopefully we'll see you next time. Take care.